Hey, welcome to week 2 of Intermediate GIS Applications for Real Estate. This is Yash Yadavalli, and this week we'll be learning about displaying data. By this time, hopefully you have finished your week 1 and you are familiar or you have reacquainted yourself with the basic principles of GIS. And from now on, we'll carry forward with this intermediate applications and learn a little bit more about GIS. So displaying data. So this covers the first 2 chapters of your GIS tutorial spatial analysis workbook 2, chapter 1 and chapter 2, which is what we'll be learning this in this class. Also, let's get started. So displaying data. We use different methodologies in displaying data. We use single symbols, we use categories, we use graduated colors to show quantities. We also use graduated symbols, proportional symbols, dot densities, and we also use charts. So how to do this, what is the best way to do this, and how to actually classify numerical data is the focus of this class, and that's what the book talks about in the first 2 chapters anyway. So let's dive right in. Displaying layers. So some basic terminology you need to be familiar with. One is symbols and the other one is renderers. So what symbols mean is they are graphic elements that are used in map displays. There are a number of symbol types. There are symbols such as marker symbols, which are primarily used for displaying point locations, and there are line symbols used to display linear features and boundaries, and there are fill symbols used in to fill polygons, and then there are text symbols used to set the font size, color, and other text properties. Anyways, and the renderer, on the other hand, is a type of display method used to draw a map layer. For example, there are renderers to fill polygons using number of categories based on unique attributes. Renderers to display shaded relief for digital elevation models. There are multiple renderers and sort of like a display methods, so to speak. So, and then we use these rendering methods, so to speak, for actually displaying attribute fields. So we also use the symbols and renderers to actually display map layers using data classes within a layer. We'll see how all this is done. So drawing so first let's focus on the very basic method, which is actually using a single symbol to show your display your map layer. So typically this is the default display using a random color, and most probably this will not suit your needs. It sort of like picks up a random pastel color and put it on the map, and it won't really look good. And you can obviously change the colors and so on and so forth, but that's the basic display method. So to actually get to the specific display properties, you need to right click on the layer, go to properties. By now hopefully you'll all know how to do this. So in this general tab, you'll be able to set the layer name and some credit, some description, probably if there is a scale based display. And in the display tab is the second tab, where you actually set the main sort of like takeaway from this display tab is the transparent variable that you set here. So if you can set like a transparency to the layer from the display tab, and also you can enable HTML hyperlinks and map tips probably, and you can actually use an expression to do so. Anyways, this is all pretty basic. And then you move on to the symbology tab, which actually allows you to choose the type of renderer you want to sort of like render your layer with. So in this example, I'm using graduated colors since this is a numeric field that I'm trying to sort of like use for my layer. So I'm going to use graduated colors, and then I picked population per square mile, which is actually looks like this is a census layer of some sort. Anyways, if we use that, also we can use graduated symbols, proportional symbols, or even dot density for the same numeric variable. And then again, you can set the number of classes here. This is set to manual right now, and then you can pick a color ramp, which essentially would be the colors in which your classes or classification would be displayed in. And then you can actually adjust your labels here, and you can choose if there is a normalization field that you want to use, you can pick it here too. So anyways, this is the symbology tab. I just wanted to show you the different aspects of it, different components of the symbology tab. So again, using the symbology tab, if you don't want to use, if this is a text field, not a numeric field, or maybe you want to use a unique value, like I don't know, you want to give each of these cities a different color, sort of a thing. Let's say this is a municipality layer, and you want to set like a unique color for each one of these cities. What you do is you click on categories, pick unique values, and then you select the attribute containing the categories, which is actually the name, and then you will identify the symbol, which color pattern you want to use. You can obviously change each one of these individually if you'd like, and then you can actually click on OK, and your map will be displayed using unique values. So unique values, many fields is another option that you can actually choose while displaying your layer by categories, because let's say in this example, you have streets, you have highways, you have streets, and they have different speed limits. And if you want to display the street by the speed limit and also the type of street, you might want to actually use unique values with many fields, so that you can display this, the speed and the type of road at the same time. So you can use 2 fields, you can use 3 fields. The maximum you can use with this is 3 fields, obviously. So that's another way of displaying your data. So some of the useful tips in working with categories is sometimes you might want to group some of these. So it's pretty easy to do that. Let's say you have I don't know, you want to group all the local roads or something like that. So you want to essentially select the symbology, or select the values that belong to the same group. You press and hold Control and select those 2, and then right click on them and say group values. Or if you want to like ungroup values, you right click on it and say ungroup values. If they are already grouped, they'll be ungrouped. So if you want to sort of like create subheadings or put them under different subtitles, what you want to do sometimes is right click on your group or like a subcategory variables, and then move them to a new heading, like you're doing in this case. And maybe you can change the label name. You can label them anything you want. So there are a couple of tips. This will make your map look much more efficient and easy to read. So you do want to consider definitely sort of like grouping and ungrouping and organizing into different groups, sort of a thing, so that your map legend becomes pretty readable. So another common render type that we use is graduated colors, which we already spoke about a little bit. So here in this case, what we want to do is we want to show the percentage of Hispanic and Latino Americans. What we want to do is we want to select the value for the value field, and then for the normalization, because since this is a percentage, we want to normalize that by the current population, which is in this case 2009 population. So once you do that, you get a bunch of ratios. These are percentages, but these are in a ratio format. So you want to classify, clean up the labels a little more by adjusting the number of decimals, changing these into percentages. Let's see. So graduated symbols, on the other hand, are used to display the same information, which is quantitative information, using graduated symbols, and these are actually grouped into ordered classes, again the same way, except that this time the entire polygon won't be filled with the color that you choose, except this will be like a symbol. It's sort of like a graduated symbol that will be representing the variable that you choose to display on the layer. So the same rules apply here. You choose graduated symbols, and then you choose the variable, and then set the legend properties for each class, and you can classify and set the number of classes here. And then if you want, you can normalize. If you do choose to normalize this by the land area, you will get density instead of actually the total population. So again, the same stuff, which we will see some of this in action during the first 2 chapters of the spatial analysis workbook. Again, using proportional symbols, what you do is go to proportional symbols and set the same. The main difference here is that the data is not classified, except that each symbol is sized to portray a feature based on the attribute value, meaning you don't actually classify these symbols, or in this case the population of the city is dynamic in the sense that the size of the dot will be proportional to the value. So in this case, you just sort of like choose the number of symbols you want to display, and then the units will multiply the field by a geographic unit to calculate the symbol size, which means it's sort of like putting them into manageable numbers. You choose your value field, and then the units, if the units are set to unknown, you can specify the symbol size perhaps, and if you set the units, it will automatically do it for you. And then you can actually control what the data represents, whether this is a. So if you choose the map units to actually calculate some of these variables automatically for you, the symbol sizes and stuff, you will get a different set of options. What it's going to ask you, what does the data represent, and it's going to let you choose the square, either a square or circle for size, symbol type. Unless you choose unknown units, then you can control some of these a little more. So that's how it's done. Using dot density could be a pretty useful map, especially when you are trying to show concentrations of population, sort of a thing. This could be a pretty useful way to display your data. So it is used to represent quantitative values based on a field value for each polygon. So it sort of like says what is the size of the dot and the dot value. What does the dot value represent? Here it is representing 50,000 population. Each dot is representing 50,000 people. You can control this, and you can say you can choose some of the options like maintaining dot density, what background you want, what color you want, stuff like that. You can have 2 or more values. For example, I usually do this for a race map. As you can see, this is the race map that I created, where each dot represents one person, and green is African Americans, blue is white, red is Asian, and orange is Hispanic. So you can sort of like see the distribution. At the same time, you are showing density also, because some of these densest areas are actually popping out a little more because they have more people in them. So this could be a pretty interesting map, as long as you use it for, as long as it fits your story. And going back, we can also use pie charts to actually represent our data. This could be pretty useful when you are trying to show more than 2 or 3 variables within the same map or on the same map. So this could be useful when you are trying to show a sort of like age distribution or race or something else, because as part of whichever actually adds up to 1, because also it helps when there are only few categories. Even here there are way too many categories for me. These are like maybe 7 or 8 categories. I would actually prefer if it was only 2 or 3, because that will be an easy to read map. So again, you click on chats, you choose pi, and then you choose the variables you want to actually compare or actually display on the map, or choose the slices of each of slices of pi and then label them, and then you pick a color scheme. You can actually control the colors if you'd like, and then you can select some more properties of pie chart, size, and the rotation if you want this to look like a 3D map or something. So the same rules apply to bar and column. If you are comparing, let's say you have population growth over maybe 6 or 7 decades or 6 or 7 years or whatever, and you want to sort of like compare it interactively on a map, this would be a fantastic opportunity to actually use a bar and column chart where you actually display this. So again, the same rules apply. You can choose, control some of these elements, the 3Ds and the depth and the how you want to actually display this information and the colors and so on. Stat charts, again an interesting way to display some variables like age perhaps, and the same rules apply to all the charts rendering methods. Now that we have seen on all the rendering methods, let's learn a little bit more, or sort of like brush up a little bit more on classifying data. So essentially classifying is a process of placing data into groups that have similar characteristics or value. So this becomes very critical, especially because this is how the map will look based on what you decide to actually choose as your classes. So breakpoints is sort of like this 9.85% is the breakpoint, 16.79, 26.92, all these are actually the breakpoints. Essentially breaks the total attribute range into all these intervals and keeps the number of intervals. So it's ideal if you keep them between 5 and 7. Sometimes I go up till 9, but that's the maximum I would go, because the more classes you have, it's much more cluttered, and you cannot really show the differentiation between all these different colors clear enough, and it becomes a little fuzzy. So essentially when you are classifying data, there are preset methods that ArcGIS provides you, sort of like mathematical progression to pick your arbitrary values. So some of these are natural breaks, which actually picks the breaks that are best. It's sort of like this is the best classification in ArcGIS, and it groups the similar values in the best possible way. And maximizes the difference between classes. And this actually, there are usually a large jumps between classes, and classes are uneven, so it could be a little tough to read. It's a subjective decision, and it is the best choice for combining similar values. So if you're looking for population, population and so on and so forth, population density or something, the similar values, so you want to use natural breaks possibly. So because when you actually use this natural breaks, since the classes are specific to individual dataset, you cannot really compare it across datasets, because it's not really, those two would not have the same classification or break values. Again, there is quantiles classification, which places the number of data values, places the same number of data values in each class, which means if you have 8 values and you are going with 4 classes, each class each class will get two values. So it will never have empty classes, or classes with too few or too many values. This is an attractive method because it actually produces a very distinct map, and analysts use it to provide information about the shape of the distribution. And equal intervals, like the name says, divides attribute values into groups that contain equal range of values. It's not the equal number of observations, instead it is the equal range of values. It sort of like best communicates with a continuous data set, and it is easy to accomplish and read, although it's not very good for clustered data. So if there are significant spatial clusters and the map produces almost a very bland map, or would not be a very good map to read. And there is exponential scales, which actually is a popular method of increasing intervals, 2 to the power of n or 3 to the power of n, and generally starts out with a 0, and then the values go up, like 0, 1 to 2, 2 to 3 to 4, 5 to 8, 9 to 16, and so on. Increasing intervals usually used for long tail distributions. Whenever the data distribution deviates from a bell-shaped curve, and are most often skewed to the right with the right tail elongated, this method is best suited for that. Keep doubling the interval of each category, like 0 to 5, 5 to 15, 15 to 35, 35 to 75, so that you have the intervals of bits 5, 10, and 20, and so forth. So let's look at an example for US state. This is a US population map. So this is what the map looks like if you use natural breaks. So sort of shows that California is the most populous state, and the rest. This is a pretty good way of actually representing the data. But if you go with equal interval, it's not so good, because too many values fall under into lower classes. If you use quantile scale, an increasing width scale is needed. So this also looks, actually this is a better map than natural breaks in this case, because it sort of reaffirms our general understanding of what the US population map should look like. And then there is custom geometric scale to the power of 2, which is also pretty good, because we have the 3 most populous states, New York, Texas, and California. And again, this actually depends on the map you pick between custom geometric, quantile, and natural breaks. Depends on the story you want to tell, because it's the same data, it's just a different way of representation. So it really depends on what you're trying to say with your map. Again, normalizing data is essentially dividing a numeric attribute with another, and in order to minimize the differences in values based on the size of the area or number of features. So if you want a percentage, you divide vacant units by total number of housing units. If you want to get density, you divide the population by, you normalize the population by land area. So non-normalized, as you can see, non-normalized population, or this is the total population, total vacant housing units, and this is the percentage of vacant housing unit, which tells an entirely different story. Even though there are more number of vacant units in California and Texas and Florida, they also have more total number of housing units, which means they have lesser percentage of vacant units. So you really need to choose a variables carefully on what you are trying. It also depends on the story you are trying to say. The same example, so San Jose, San Francisco and San Diego are not the most populous states according to this map, but if you actually change it to population per square mile, which is normalizing it by total land area, you will get a much better map. So again, some tips for improving your layer display is using color transparency, perhaps. If you want to, again, drawing order of the features is pretty critical, which we'll learn about, which we'll look at in the walkthrough. And then you can probably use some effects toolbar to actually display and flash features, and also you need to create useful and effective symbol legends that appear in the table of contents and in page layouts. So some of these have links to RGS resources. If you want to look them up, that would be fantastic. Again, a fantastic source for cartographers is RGS Mapping Center. It's a blog which has immense library of great maps. You would get really good ideas on how to actually display your data. So that's the presentation. Let's go into our walkthrough.